Dopamine is a major neurotransmitter that plays a crucial role in motivation, productivity, and focus. Lifestyle habits, diet, and illness can play a key role in regulating dopamine levels, which, if mismanaged, can leave us feeling lethargic, apathetic, and unmotivated. To trace the source of motivation, let us begin in the brain, where neurotransmitters spark chemical messages to keep us alert and on task. Neurotransmitters carry chemical messages that play out in the brain and affect the rest of the body. One neurotransmitter that plays a role in the science of motivation is dopamine. Dopamine's chemical signal gets passed from one neuron to the next, and between those two neurons, dopamine interacts with various receptors inside the synapse. This arrangement becomes much more complicated when you multiply the effect through the entire brain, considering that there are different types of receptors, neurons, and pathways that neurotransmitters can take. For motivation precisely, it matters which pathway dopamine takes. The mesolimbic pathway, which comes from the middle of the brain, branches to various places like the prefrontal cortex and is the most important pathway in the brain associated with reward. One of the stops within the mesolimbic pathway is the nucleus accumbens. When there is an increased amount of dopamine in the nucleus accumbens, it triggers feedback for predicting rewards. Essentially, our brain recognizes that something important is about to happen, so dopamine kicks in anticipation of it, and makes us aware and more motivated to act carefully. The reasoning for the development of this mechanism was to ensure safe decisions were made in situations that were a case of life or death. If it were a successful decision, massive quantities of dopamine would surge, thus ensuring that decision and the stimuli associated with that event is remembered. To envision this, let us think of ourselves as cavemen in a wild environment that we had not quite figured out, and we are on the search for food, and our visual system suddenly detects a lovely colored fruit within a tree. Either we try it and get poisoned, or we eat it and do not get poisoned, and it tastes phenomenal. Now, what do you think would happen to our dopamine in the latter portion of this equation? If you guess that it surges significantly throughout our body, you'd be right. The reason for this is because our visual acuity from our visual systems enjoying with our limbic systems pick up unique stimuli such as colors and distinctive shapes, which can cause a surge of dopamine that tends to make us curious and investigative. Hence, this is why many researchers also tend to refer dopamine as the archaic molecule of risk and reward, or put more simply, the molecule for learning. As Yukon researcher John Solomon explained, low levels of dopamine make people and other animals less likely to work for things and to take risks. So it has more to do with the motivation of cost-benefit analysis than pleasure itself. So to conclude these learnings, the brain feeds off bursts of dopamine sparked by potentially rewarding experiences. The external world creates the dopamine environment, and the brain does the rest to motivate us to act on the stimuli, sometimes either instinctively or decidedly. Thank you for listening.